The final project in analysis and design of a tall building. You have applied the dead and live loads on the building model. Now you will learn to apply one final set of loads, that is, the wind loads to the external claddings. You can notice that the building section is not uniform throughout the height of the building. Thus the windward-facing shells will be in more than one elevation section. If we consider that the wind is blowing from the left side, then it will directly hit some claddings of the section A, and some claddings of section B, depending on the story. So you have to carefully select the claddings section-wise, with respect to each side of the building. You will understand more clearly, as we proceed with the steps. First, define the wind load. Go to the Define menu, and select Load Patterns. Type the load name as wind. Select the load type as wind. And in the Auto Lateral Load option, select the IS code for wind loads, that is IS 875. Then click on Add New Load, and the new load will be added in the list. Select the newly added wind load, and click on Modify Lateral Load. Here, for the wind load settings, we have to refer to the IS 875, Part 3. Open the IS code, and scroll down to the map, for wind speeds. Considering the building to be built in Bangalore, the corresponding wind speed comes to be 33 meters per second. Enter the wind speed value of 33 meters per second in the software. For the terrain category, refer to the clause 5.3.2.1. The terrain of Bangalore falls under category 3. So select the terrain category as 3 in E-tabs. For the structure class, the height of the building is more than 50 meters, so select the structure class as C. As discussed earlier, take the risk coefficient value as 1, considering the mean design life of the building as 50 years. For Bangalore, the upward wind slope will be less than 3 degrees. So take the topography factor, K3 as 1. Click on OK, to store the settings of the wind load. Click on OK to exit the Load Patterns dialog box. You will now be assigning the wind loads onto the building claddings. With the Plan View tab selected, click on the Elevation option. Select the elevation side A, and click on OK. Select the All Stories option, and select all the cladding shells. To identify the wind pressure coefficients, open the IS code again, and scroll down to Table 4. The height of the building is 23 times 3, which comes to 69 meters. The width and length of the building are both 18 meters. Thus the height by width ratio is 69 by 18, which comes to 3.83. As the value is between 1.5 and 6, go to the particular subcategory of height by width ratio. The length and width are both 18 meters, so length by width ratio is 1. Hence go to the subcategory of length by width ratio between 1 and 3 by 2. Check for the wind pressure coefficients under this category. The coefficients are plus 0.8, minus 0.25, minus 0.8, and minus 0.8, for sides A, B, C and E respectively, as per the building plan on the IS code. Now, in the software, the shells are already selected. So go to Assign, Shell Loads, and click on Wind Pressure. Change the coefficient value to plus 0.8, and select the Windward option. Then click on Apply. The wind load has been applied to the section A. OK, exit. As visible from the 3D model, the side A of the building plan in the IS code also corresponds to some shells of the section B, in the higher stories. Select the Elevation option, and select the section B. Click on OK. The remaining claddings in the windward side of the building, which will be subject to the wind loads, are visible. Using the All Stories option, select all the shells. Apply the same wind pressure coefficient, of plus 0.8 in the windward direction, to these shells. Once wind load is applied, go to the Plan View option and select Story 1. And click on OK. Now the opposite side of the windward direction, that is the side B from the IS code, corresponds to sections C and D, for different stories. First go to the elevation view, select section D, and click on OK. Select all the shells, with the All Stories option. The corresponding wind pressure coefficient for this side is minus 0.25. Select the wind pressure coefficient option from shell loads under the Assign menu. Enter the coefficient value of minus 0.25, and select the leeward or sides direction option. Click on Apply, and click on OK. The wind load is applied in section D. Go to the Elevation View option, and select section C. The wind load in this section will also be minus 0.25. So select the visible shells, and apply the wind pressure coefficient of minus 0.25, in a similar manner. The wind loads on sides A and B, as per the IS code, has been applied. Now you will apply the wind loads on the other two sides, which have the same wind pressure coefficient of minus 0.8. In the Elevation option, select section 1, and click on OK. Select all the shells, using the All Stories option. Since the coefficients are same in the other sections also, you can select them together, using the up and down arrow keys. Navigate to the elevation sections 2, 3, and 4, and select all shells in each section. Once all the shells are selected, go to the Assign menu, select Shell Loads, and click on Wind Pressure Coefficients. Here change the coefficient value to minus 0.8, select the leeward or sides, and click on Apply. The wind load in the elevation sections 1, 2, 3, and 4 have been applied. The software will automatically understand the exterior surface of the shells in each section, and thus apply the direction accordingly. You can check the loads from the Plan View. Click on OK to exit. Go to the Plan View option. Select Story 1 and click on OK. The loads are applied in all the shells, in each side. Go to any story from the second set of similar stories. For instance, go to Story 10 by selecting Plan View and choosing the story. You can see that the loads are applied to the exterior shells, even if they are in an interior grid section, and the directions are also correctly set. In this way, you can verify the wind loads and directions in the other sets of similar stories as well. In the next part, you will learn to run analysis and design on this building model. Thanks for watching.